To refresh your memory, the probability is the number between 0 and 1 that describes the proportion of times an outcome would occur in a very long series of repetitions. The law of large numbers is a principle of proportion that states the more repetitions of any chance process, the closer a proportion of a specific outcome will approach a single value. A common mistake is mixing up the law of large numbers with the law of averages. The law of averages states that over many repetitions, the wins and losses will eventually balance out.
Our first probability rule states that for any event A, 0 is less than or equal to A, which is less than or equal to 1, and the probability of our sample space is 1. If the events have equally likely outcomes, then the probability of A equals the number of outcomes corresponding to event A over the total number of outcomes in the sample space. The complement rule says that in order to find the probability of the complement of event A, you would just take 1 minus the probability of event A. The general addition rule states that the probability of A or B equals the probability of A plus the probability of B. When two events are mutually exclusive, then the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. This is a rule that applies for conditional probability. Conditional probability is the probability that one event will happen given that another event has already occurred. Lastly, we have the general multiplication rule, which states that the probability of A and B equals the probability of A times the probability of B given that A has already occurred.
So when you first learn about probability, you'll probably see a lot of symbols like the upside down U, which is also known as intersection, and it represents and. So when you see P of A intersection B, it stands for the probability of A and B. Another symbol is the symbol that looks like a U, which stands for union and it represents or. So when you see P of A union B, it stands for the probability of A or B. If you want to find out if two events are mutually exclusive, then you have to find out if P of A and B is equal to 0. And if they are, then the two events are mutually exclusive. So if you want to find out if two events are independent, there are actually 3 ways of figuring it out. You could check to see if P of B sub A is equal to P of B, or there's P of A sub B, which is equal to the probability of A, and there's also the probability of A and B is equal to the probability of A times the probability of B. And those are the 3 ways to figure out if two events are independent. Now I'll go over some common mistakes with probability. So the order of events is only important for conditional probability, which is like P of A sub B is different from P of B sub A. And then, so there's also another common mistake where two events cannot be mutually exclusive and independent at the same time.
A two-way table is used to compare two events. For example, we are comparing the number of girls and boys that choose to be inside or outside over the week. The numbers circled in red are conditional probabilities, and the numbers circled in black are marginal probabilities. If you are given a problem involving two events, you can use a two-way table to help fill in missing information by using the marginal and conditional probabilities.
A Venn diagram is a probability model that can display the probabilities of A or B occurring, A and B occurring, or neither A or B occurring. And if you add all of the probabilities up, you should get 1, which is the size of the sample space. For instance here, the probability of A or B happening would be 0.4 plus 0.2, or 0.6. The probability of A and B occurring would be 0.3, and the probability of neither would be 0.1.
So in order to understand tree diagrams, I'll be using an example of flipping the coins twice, where the events possible are heads, 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 tails, tails, heads, and tails, tails. So basically at the starting point, we flip the coin first, and there's a 50% chance for heads and a 50% chance for tails. And based on that option from the first one, we flip the coin again. And now we have another branch of heads and tails for the heads tree and heads and tails for the tails tree. So basically, in order to get 25% probability for heads or something like that, we'd have to do 50% times 50% to get 25%. And that's how you get the end probability, by just multiplying the first probability by the second probability. And just to note that there could be many more branches, but I only use 2 because it's simplistic and it fits the example.